Good morning, good afternoon, and good evening, everybody. I am Gilbert Haddad, a data science advisor from Spark Ignition. I will be talking to you today regarding automated model building, which is what we consider to be the frontier of AI. So I'm going to start talking a little bit about the company, who we are, what we do, and then talk about automated model building, and then how is it improving our processes, and then how is it an integral part of our products, and then some of the applications that we have today. So a little bit about us. So we launched a company in 2014. Our CEO Amir. So we're a little bit more than 3 years old. We're more than 150 people. We have had a spectacular growth. This is just a little bit of our board members and our advisors. We are very, very well connected to the academic space, and hence we keep up with the latest and the greatest in the AI space. A little bit more about our company. This is just some of our partners and then investors and sponsors. As you see, I'm not going to direct deeper into any of them. We have quite a few sponsors. We have quite a few investors, and then quite a few partners. So if we look a little bit about the value proposition of IoT or industrial analytics, so industrial companies today suffer $1 trillion in operational losses today. So this is from Emerson. And as you can imagine, the losses could be due to many, many things. Either cost of downtime, operational issues, efficiencies, reliability, you name it. Any piece of equipment that's failing is going to have substantial costs associated with it. And typically the costs are much more than the actual replacement of a particular widget. Take, for example, a wind turbine that we see here in the background. If you have a bearing problem, the cost of failure is not only the bearing, but it's a little bit more than that. The power, the downtime, the contract, if you have an availability contract, and then so on and so forth. Now, when we look at the building blocks of artificial intelligence, so we consider artificial intelligence not only machine learning. There's few elements to it. The first one is automated model building. So how do you deploy the capacity to train models automatically, deploy them, and then after you deploy them, keep retraining them on the fly? This is extremely important because models age, your application is going to have evolved over time, and being able to retrain it automatically is extremely important. The next one is NLP, or natural language processing and vision. Now, getting data and insight from NLP and from textual information and image information is extremely important. The algorithms to be able to do that are critical and slightly different than the other algorithms we see elsewhere. Deep learning and reasoning algorithms. Over the last few years, 5, 6, 7 years, you've had substantial improvements in deep learning, and then the technology is slightly different, and it is really a building block for AI. The last but not least is the powerful visualization with evidential insight. Is when you deploy AI, how do you actually explain it? How do you get the most out of your AI? And this is what we consider the building blocks. What I'm going to talk about today is automated model building, how it works, our patented technology, and then how it is embedded into our products. Now, AI today, if you look at some of the applications, as I'm sure you've seen throughout the conference, there's quite a few applications today. One from remote vision, radar and LiDAR, image processing, sound isolation. There's quite a few applications today that are very, very successful. And I'm not going to drill deeper into any of them. But really the power of AI is when you put it with your subject matter experts. We really believe in an interaction of the team members and the AI, and this is really when you can take the value and then get the most out of your artificial intelligence. For us to do that, we have developed a number of products that are used by the subject matter experts in the industrial companies, and really deliver the value of AI. So our products are Spark Predict, which is, it takes the physical assets and then does the analysis and the prediction. This is really the predictive maintenance part of our application. The second one is Deep Armor, which is malware detection using AI. The third one is Deep NLP, which is natural language processing, extracting information from textual data. And then last but not least is Spark Secure, which is cloud security, threat intelligence, and advisory. Now, as an input to all of them, or a building block behind all of these products, we have AMB, Automated Model Building, which is really a spectacular piece of technology that allows us to develop our technologies much, much faster, build models quicker, and make sure we develop the best models out there. I'll talk briefly about automated model building and then how is it an integral part of and all the other applications that we have. So AMB, or automated model building, is our patent technology by which we take all the inputs, sensor data, we feed them into a network, and then we do the input-output mapping. Now, not only we do it once, we do it over and over and over again. And then we use genetic algorithms to be able to select the best models in every generation. So if you're familiar with genetic algorithms, we do selection across every generation, and then we keep on selecting the best models until we end up with a model that satisfies us and then solves the problem very, very well. And then you end up with a great model. Now, that it doesn't end there. So you can actually take the model and then keep retraining and developing more models and then fuse all of them together in order to end up with a meta model that works across all your application. Now, why is this beneficial? Because it searches through very complex topologies of deep learning algorithms, combines the best out of all of them, comes up with the model that works the best for your data, and solves it in the most effective and efficient way. You don't have to search a very big space and run through thousands or millions of iterations. We have a very, very clever way to do it with genetic algorithms, and then gets you through the answer much, much faster than anything else that I've seen. Now, this is very important because our data scientists started to use it to accelerate their job. And then as of recently, we noticed that there's quite a bit of demand from the industrial space for that. Now, naturally, we take that technology and we embed it into our multiple products, because if we have a product for predictive maintenance, you might expect that this is a critical piece of technology that should be under the hood. So Spark Predict is our platform for predictive maintenance. So you connect it to your data, to your asset, and it builds asset models automatically. Now the asset models, whether it's a wind turbine or a gas turbine or you name it, it builds the models with AMB automatically and deploys them through the platform to show when your asset is going to fail or it's going to have an issue. You can incorporate your domain expertise for supervised learning, although you don't have to. And then it delivers advanced data cleansing and verification technique. So with one platform, you are able to connect your data, build the model automatically, and be able to predict when your piece of equipment is going to fail. Spark Predict is used with some of the largest companies in the world today, and we're very, very proud of our partners that are using it. This is one of the examples of Spark Predict on a turbine. So we take the data, you feed it through the platform, and then it just predicts whether it's an operational, in a normal operating state or an abnormal operating state. And the domain experts can look and then really diagnose and then drill deeper into the root cause of the problem. So one of the benefits that Spark Predict, one of our clients, which I can't really mention here, but they took Spark Predict, they connected to their assets, and they were able to identify manufacturing defects within 4 months of installation, which is really a game changer for our clients. And then they realized an issue that they were not able to identify otherwise. Another piece of technology that we have is Deep NLP, which is natural language processing. So we're able to ingest a large number of PDF documents in the thousands and tens of thousands of documents, and we're able to query them with natural language processing, also powered by our AI. So we delivered major solution for one of the largest aerospace companies in the world. And you can conduct machine-to-human dialogue. You can ask any question from all your PDFs and get the answer, which is really groundbreaking in the space of AI. And then that can improve your maintenance efficiency, your troubleshooting time, and so on and so forth. Just a little bit about how do we go about problems, and then how do you use A and B and then any of the technologies. The guiding principle is we first engage with our clients with the problems where the cost to repair, where it's costly to repair or to replace, so the cost of failure is very high, and a high number of faults. So we take these applications, we take the data, first we feed it to A and B and make sure that we're able to deliver a solution or a model, and we're able to predict the failure. Then we put it into Spark Predict if it's a time series, or we use it with NLP if there is textual data that we can use. And you can often use both of them in conjunction, which is really where the power of AI lies. So this is really what I had regarding artificial intelligence, automated model building, and Spark Predict, and how it's used in Spark Predict. I hope you enjoyed it, and thank you.